Hello and welcome. In my last few videos we went through how to find areas underneath curves or functions using integration, and we also learned how to find areas in between two functions as well. But another cool thing that we can do with integration is to find the volume of a function, of an arbitrary function, say the one that I'm drawing now, which I'll call f of x. The volume of a function between a defined interval, revolved around the x-axis. So let's say that I have the interval a to b. I can use integration not only to find the area underneath the curve, but I can also find, as I mentioned, the revolved volume. So I can use integration to find the volume of this solid. And how would I go about doing that? Let's have a look at one of the simplest cases. Let's say that my function f of x was simply a constant, which means it's just a straight line parallel to the x-axis. And that's my best representation of a straight line. And let's say it has a value of r. So it is at a distance r above the x-axis. And let's say that our interval is between the origin and at the point h along the x-axis. So we have the distance h here. Well, if I was to revolve this around the x-axis, I would simply just get a cylinder. And the volume of a cylinder is given by pi r squared h. And our integral equation is going to take on this form. So for an arbitrary function, we want to somehow incorporate our f of x into this r squared term. And to do that, I'm going to start by slicing this arbitrary function f of x into strips. And I'm going to let me zoom in on one of these strips. So let me zoom in on one of these strips. So zooming in on this strip. So if I draw a rough x-axis and my function, the height of my function I'm going to approximate is going to be in the middle of this strip. So this point here is f of x at the ith strip, and the width of this strip I will call delta x. So if I was to revolve this strip around the x-axis, this particular strip would have a volume of, so v of xi of the ith strip is equal to pi times f of xi squared, or I would let me write that clearer. So the height of the function squared times delta x. So it'll follow then that the total volume would be all of these strips the volumes of all of these strips added together. So I can say that V is equal to the sum from I is equal to 1 to I is equal to n. So we have a certain number of strips of pi times f of x of the ith strip squared delta x. And we know that this is just an approximation at the moment because we have a certain number of strips, or we have a certain width for the strips, and this volume would become increasingly accurate and converge to the actual volume if we take the limit as the width of the strips goes to 0, or if we increase the number of strips from a finite number of strips to an infinite number of strips. So we can rewrite this equation if we like to actually narrow these strips so they eventually become widthless. So I could write that as the limit as delta x approaches 0, delta x approaches 0 of the sum from I is equal to 1 to n of pi times the square of the function at the ith strip times delta x. And this is a form of Riemann sum which can be expressed as an integral. So I'm going to write that. I've run out of space here. I'm going to write it up here. So in other words, we can write this v as this constant pi can come out the front, pi times the integral from 0 to h of f of x squared, and to be less confusing, I'm going to write this squared above between the f and the parentheses, dx. And this is the formula that we would use to find the volume of a revolved function about the x-axis. So let's go ahead and do an example. Okay, here I have the function f of x equals 3 divided by x plus 2 all squared. And this function is bounded by the interval of, well, the y-axis, and x is equal to 1. So our formula for the volume of this function revolved around the x-axis between this interval is given by v is equal to pi times the integral of x equals a to x equals b of f squared x, or f of x squared dx. I'm going to make things a bit simpler by first evaluating what f of x squared is equal to. So effectively we're going to get 3 divided by x plus 2 all squared, and we're going to square it, and we're going to get 9 divided by x plus 2 to the fourth. And a better way of writing this for integration purposes, I believe, is to write it as 9 times x plus 2 to the power of negative 4. So our integral becomes, so v is equal to the pi times a integral from x equals 0 to x equals 1 of 9 times x plus 2 all to the power of negative 4 with respect to x. And this 9 can come out the front as a constant, so 9 pi times the integral from 0 to 1 of x plus 2 to the power of negative 4 dx. Okay, so the antiderivative of x plus 2 to the power of negative 4 is simply x plus 2 to the power of negative 3 divided by negative 3, and that is bounded by the upper limit of 1 and the lower limit of 0, and the 9 pi stays at the front as a constant. And I can see that I can bring out this negative 3 at the front as well, so the 9 can cancel with negative 3 to become negative 3 pi times x plus 2 to the power of negative 3 bounded by 1 and 0. So to evaluate, I just sub in for x is equal to 1 minus x is equal to 0. So I'm running out a bit of space, so I'm going to continue down here. Negative 3 pi remains out the front, and I will be left with 1 plus 2 to the power of negative 3 minus 0 plus 2 to the power of negative 3, which equals negative 3 pi times 3 to the power of negative 3 minus 2 to the power of negative 3. And that's equivalent to 3 pi, negative 3 pi times 1 on 3 to the power of 3 minus 1 on 2 to the power of negative 1 on 2 to the power of 3. And these fractions evaluate to 3 pi times 1 on 27 minus, I'm running out of room, but let's persist on, 1 on 8. And now I have to get a common denominator between this 1 on 27 and 1 on 8. So I can write the top, the numerator, as 8 minus 27, and then just multiply the two denominators together. So 27 times 8 will give me, so 7 times 8 is 56, and 2 times 8 is 16, so that will give me 216. And negative 3 and 216 will simplify down to negative 1 on 72 pi, and then 8 minus 27 will give me negative 19. So the two negatives cancel, and I'll get 19 on 72 pi. So this is the value, and to show that I have a volume, I should write units cubed. And that's how you would find a volume of a function revolved around the x-axis. So I hope this video has helped you better understand this concept. Please give me a like if it has helped in any way, and I shall see you on the next video. If you are currently studying math, please feel free to subscribe to my channel for future videos that may help you on exams or assignments. And as always, please feel free to ask me any question by commenting on any of the videos that you've seen. Thanks for watching, and I hope you've learned something.